So what that means is, okay, this is kind of just like an arbitrary thing they're asking us to do. We're given this rational function right here, 3x over x plus 3, and it's asking us to just rewrite this as an equivalent rational expression that has the denominator of x plus 3 plus x plus 5. So you can see right now, our expression only has an x plus 3 in it. They want us to have a denominator of x plus 3 times x plus 5. Okay? And there's no real reason for it right now, except that's just what they asked us to do. We'll see later why we want to have that kind of skill. Why is that why that's useful, and you might be able to figure it out based on the warm up too a little bit. Okay, but that's the idea there. Okay, so you can see here that our denominator is missing. Well, sorry, the denominator has x plus 3 already in it. The factor missing from the denominator is x plus 5, right? If we want our denominator to be x plus 3 times x plus 5, we need to rewrite this thing so that it has another x plus 5. So how do we do it? Well, we introduce a common factor, x plus 5. We start with the original, and what do? We just multiply by x plus 5 over x plus 5. Okay. When I'm multiplying something by x plus 5 over x plus 5, what value am I really multiplying by? 1. And when you multiply something by 1, are you changing its value? No. So that means this thing should be exactly the same as this thing, because all we're doing is multiplying by 1. But by multiplying this way, we end up with a denominator that has both x plus 3 and x plus 5. So we kind of like did what they asked us to do. We rewrote this thing as an equivalent rational expression that has a denominator now with just the x plus 3 and x plus 5. There it is. Okay? So let's go to this one here. Okay, now this one asks us to simplify the expression. Simplify the expression here. Okay? So if this is our... That's exciting. I feel like we're in prison in the South or something like that, and there's like, playing their harmonica, You guys are like, it feels like we're in prison here every day. Well, I'm sorry. Okay.
If I flip the desk over and put the basement here.
There you go. See, you're like, let me in.
So I can't put the basement with mine.
I have, not for anything illegal though. I chose to be there. So,
was it a scared straight thing?
What's that?
Was it a scared straight thing?
No, I chose to be there.
Oh, were you visiting family?
I was visiting someone that I knew, yeah. So,
were they in the drunk tank, or was it something more serious?
More serious.
Okay.
Assault.
I'll stop pressing.
Yeah, that's okay. So anyway, so x squared plus 5x plus 6, we want to simplify that with something from the denominator. Now, in order to simplify this, what do we actually need to do here? Any ideas?
Factor.
We got a factor. Exactly right, okay? We see a quadratic here. We know quadratics sometimes factor. And in fact, well, you can see here, that's what the directions tell us to do. Factor the numerator and the denominator. So can we think of two numbers that multiply to 6 but add to 5? 2 and 3. What about the denominator here? What about this x squared plus 3x plus 2? Does that factor? Yeah, two numbers that multiply to 2 but add to 3, that would be 2 and 1. So we'd have x plus 2, x plus 1, and then there's that x plus 3 there. Okay. Sure. So then, what can we divide out here? What cancels out now? X plus 2's cancel, x plus 3's cancel. So what's going to be left in my numerator? Since both those cancel, what value is left?
X plus 1.
So the x plus 1 in the denominator, yep. But what's left in the numerator? Both things canceled out. It's a 1. And so that's our final answer. Okay? So here we simplified to get an equivalent. We cancel things out to get an equivalent rational expression.
What would make it a 1 in the numerator, not a 0?
We'll make it a 1. Very good. When I say cancel out the x plus 2's or cancel out the x plus 3's, that's not a mathematical term. We're dividing. When you divide something by itself, it's a 1. Divide this thing by itself, it's a 1. So what's left? A 1. Because 1 times 1, they cancel out. It's a 1. Okay? Yeah. I gotta be careful. Cancel means a lot of different things in a lot of different situations. So really, we're dividing. Okay? All right, so number 2, let's look at this one. Okay, we'll do this one together, and then maybe we'll try 3 as well, just to see. Okay, so number 2 says, rewrite this as an equivalent expression with a denominator of x minus 5 times x plus 1. So if you look right here, does this have a denominator of x minus 5 times x plus 1? What do we say? Yeah, no, right? It's not. So let's see here. So 5 over 5 5x minus 25. And we want to get it so that it's got an x minus 5 in the denominator and an x plus 1 in the denominator.
GCF to get that.
Right, so if you guys notice here, there's a GCF. What can we factor out of the denominator?
5.
A 5, right? So both those divide by 5. So let's pull out a 5 there first. And if I factor a 5 out of this, what's going to be left here?
X negative 5.
X minus 5. You got it. That's fine. And so then the 5s simplify and cancel, right? What's left in the numerator? 1 over, and then what's left in the denominator? Just an x minus 5. Okay, great. That was helpful because now we've got an x minus 5. What else is missing from our denominator? Right, we want an x plus 1. Oh, I'll just multiply an x plus 1 in there. But of course, I can't just bring in this x plus 1 in the denominator. I'm going to also multiply by x plus 1 in the numerator. Okay? Because isn't this just multiplying overall by 1, right? Isn't this value just 1? So if I take this thing and multiply by 1, I'm not changing the value at all. It stays the same value, but it just looks different. So now I have x plus 1 over, I'm not going to multiply it out, I'm going to leave it unmultiplied there. Okay? So now I have x plus 1 over x minus 5 times x plus 1. I'm done. I did what it asked me to do. Write that as an equivalent expression for the denominator of x minus 5 times x plus 1. That's it. That's all we have to do. Okay? So if you think about it, we're kind of like getting like terms here. We took a denominator, a fraction, we simplified it some, right? And then we wanted to get a common denominator of this. Our denominator that we had was missing the x plus 1, so what do? We multiply by x plus 1 over x plus 1. Earlier, when we did 1/6 plus 1/2, okay, you can think of this 1/6 as 1 over 2 times 3. What is this? Oh, sorry, this denominator has a 2 and a 3 in it being multiplied together. This denominator is missing what? A 3. So we multiply by 3 over 3 to get a common denominator. And now we can add those numerators together. And the 4 and the 2 can cancel. And we end up with 2/3, right? 1/6 plus 1/2 was 2/3 there. It's the same principle here. We just have two variables in there. That's all. Okay? We had this. We factored out the 5 so they could cancel. We're left with 1 over x minus 5. And then we're missing an x plus 1 in the denominator that we want. So we just multiply by x plus 1 over x plus 1. And boom, there it is. We're done. Okay? And again, this is not a typical kind of question. We're leading up to that typical kind of question. But right now we're just with this baby step. Okay? Number 3. Simplify this expression. How do you think we should go about trying to simplify this expression here? Ideas. Okay, so for example, this x plus x cubed, there's a GCF in there, isn't there? What can I factor out of that? Just an x. So this becomes x times x plus x squared. Oops, sorry, 1 plus x squared. Goodness, I'll just do it this way. X times 1 plus x squared. Okay. And what about 1 minus x squared? That's a difference of squares. It's 1 minus x times 1 plus x. All over. And then the denominator. What can I factor out of the denominator? Yeah, the GCF of x squared there, right? They both have I can take an x squared out. And that leaves behind 1 minus x to the 4th. Which I can factor, believe it or not, I can factor that 1 minus x to the 4th. So let me factor one more time here. 1 minus x to the 4th is the same as 1 minus x squared times 1 plus x squared. And that 1 minus x squared also factors once more. So this one factors a ridiculous amount here. Okay, this one's a little ridiculous, but anyway, well, there it is. Okay, so you factored it all out. You can GCF out of the denominator of x squared. 1 minus x to the fourth is the difference of squares. 1 minus x squared times 1 plus x squared. 1 minus x squared is another difference of squares. 1 minus x times 1 plus x. Okay, and then we're left with all this. So now, what cancels?
X minus 1 is x plus 1.
Okay, so the 1 minus x cancels the 1 minus x. The 1 plus x cancels the 1 plus x.
1 plus x squared.
The 1 plus x squareds cancel.
X over x squared.
Yeah, so x over x squared. So if I cancel this x out, what's going to be left behind from the x squared? Just an x. And so this whole thing simplifies to just that. 1 over x. Okay. Wow. All that canceled out and just left with 1 over x. Okay, it's pretty satisfying. Getting all that mess to then cancel out so much. Okay. All right. So, now let's use this skill, okay, and talk about trying to find common denominators between rational expressions. So now we're going to try and find a common denominator between these two fractions. Okay, and that might seem a little daunting here because they're like, oh, these seem so different. There's like subtraction, addition, there's x's and stuff like that, but it's actually not that bad. The first thing you want to do, okay, as you can see here in letter A, is to factor each denominator completely. So you see they take the 3x minus 15, and we factor out a 3, right? Because both the 3 and the 15 can be divided by 3. And then likewise here, the 4x plus 28 is equal to 4 times x plus 7. Okay? And so what I like to do is rewrite the fraction here. I'm going to do it down here because I have space. So this is negative 2 over 3 times x minus 5 plus, or not plus, it's just and 6x over 4 times x plus 7. Okay. Do these two denominators have anything in common? Do these two denominators have anything in common?
Yeah.
This one's got a 3, sorry?
They have an x in both.
They do have an x, but this one's really an x minus 5 because that's one quantity, and this is x plus 7 there. Okay? So they do both have an x, but the problem is this is x minus 5, this is x plus 7. So what this means is they have nothing in common right now. Okay? This has a 3, this one does not have a 3 over here. This one's got a 4, but there's no 4 over here. This has an x minus 5, this does not have an x plus 5. This has an x plus 7, this does not have an x plus 7.
Both got numbers in them.
So what that means is to get our least common denominator here, this denominator needs a 4, this denominator needs a 3, this denominator needs an x plus 7, this denominator needs an x minus 5. And so the least common denominator is going to be 3 times 4 times the x minus 5 times the x plus 7. They don't have anything in common, so you have to put everything together. Okay? The first denominator has nothing in common with the second denominator, so the least common denominator is to put it all together. 3 times 4 times x minus 5 times x plus 7. And that's why we end up with this, or if you multiply the 3 and the 4, you get the 12 times the x minus 5 times the x plus 7. Okay? Okay. This goes back to the idea of like the 1/4 plus the 1/5 that we did for that warm-up problem. 1 over 4, I can actually break that apart and say it's 1 over 2 times 2. Right? The 5 and these two 2's, there's nothing in common between these two denominators. So to get that common denominator, I need to multiply the 2 times the 2 times the 5, which gave me 20. And that was my common denominator, right? That ended up being my common denominator here. Here for this problem, the 1/6 plus 1/2, if I break up that 6 into 2 and a 3, this fraction already had a 2 in it. So all of this fraction was missing was a 3. I didn't have to do anything to change this problem. I just had to get a 3 in this denominator to get a common denominator. Okay, that's all it was missing. Okay? So let's look here. Letter B. Now we have quadratics for our denominators. Let's factor here and see what happens. So let's see here. This one's going to factor to x minus 8 times x minus 3. And this one's going to factor to x minus 3 times x minus 3. Okay? So you'll notice they both have an x minus 3 in common. They both have an x minus 3 in common. But what is this one missing that this one has? Right. This right here is missing an x minus 8. So the denominator, this denominator is missing an x minus 8. And this denominator here, what is this one missing that this one has? Right. This one's got one x minus 3, but it needs two x minus 3 to be able to match up. Okay. So our least common denominator is going to be x minus 8. Okay. Because we need one of those. And we need two x minus 3s. Okay. And two x minus 3s. Okay. So let's actually get to a problem where we're actually going to try and add these things. Okay, let's see here. Oh, question, AJ? Sure. Go ahead. All right, so let's see. I'm going to go to... Goodness, how do you make this a little bit harder than I want it to be to start out here? Okay, let's try a simple one. I'm going to actually skip over to page 429. I'm going to show you one. So I'm going to use some of this blank space here, okay, on page 429. So let's go to like the... I'm going to kind of cut the page in half here and just use some of this space because I don't like... I think some of the problems they have you guys start out with are just a little bit too much. Okay, so let's say we wanted to add 3 over x plus 5 over, I don't know, x squared plus x, like that. Okay, let's say we wanted to add these two things together. Okay. Again, don't worry that we have variables in here. The idea of adding these fractions is the same as what we've seen in the past when you add normal fractions. Okay? So, what do we need in order to add fractions?
Common denominator.
Common denominator. Okay? Do we have common denominators right here?
Yes.
We do. They're the same.
These are X?
They both have an x. That's good. That's good. But are they exactly the same? No, right? No. So let's rewrite this bottom one. I think the second one here, I can see it factors, right? So let's write that as 3 over x plus 5 over this. We can factor an x out here, so it's x times x plus 1. Okay. So if Stephanie's right, they both have an x. They both have an x, but what is not shared between the two of them? What don't they share in common?
Plus 1.
The x plus 1. They both have an x, but one has x plus 1, one does not. So, to get a what's our common denominator going to be? We need to multiply this denominator by an x plus 1 to fix it, right? To make it a common denominator. So we'll multiply by x plus 1 over x plus 1. I'm going to kind of squeeze it in there. Okay. I'll put parentheses around the x plus 1 there. Okay. So what does that give us? Well, the 3 will get multiplied with x plus 1. And they're going to have x times x plus 1. Okay, like that. Now that 3 over x has a denominator of x times x plus 1, and there's an x plus 1 in the numerator there. Okay, to convert it. So questions. That's what we're going to be doing here. Okay, that's what we were leading up to. This is what we're leading up to right here. So any questions so far? Anything that's unclear or confusing, or you're just not really sure where anything came from? This is what we're leading towards right here. Okay, so if you're not getting this, you want to ask right now. Okay, so any questions thus far? So we have common denominators. Now we can just add these two things together. So I'm going to combine this together as one fraction. One fraction, one denominator. I'm just going to add together the numerators. Like that. Isn't that what we did here? 1/6 plus 1/2. The 6 had a 2 and a 3, right? It's 2 times 3. This 2 is missing a 3, so we multiply by 3 over 3. We got a common denominator. We added the numerators together, 4 over 2 times 3, and then we could simplify some too. Question? Sure. Okay, distribute the 3. To simplify here, 3 times x is 3x, 3 times 1 is 3, plus the 5 over x times x plus 1, and so we get 3x plus 8 over x times x plus 1. Okay? And we're done. We added the fractions together. Okay? Questions on that? Let's try another one. Okay. Let's add 7 over 9x squared plus x over 3x squared plus 3x. Okay, let's see if I can do this. Okay, there we go. Do we have common denominators? Nope. Alright, so let's see what we can do here. It looks like I can factor something out of my second denominator again, so I'm going to rewrite this as 7 over 9x squared plus x over, okay, and then let's go to, so Miranda, do you see, what can we factor out from both of these terms here? A 3x, very good. If I factor 3x out, I'm going to be left with an x here and a plus 1 here, right? 3x squared dividing out of 3x, I'm left with just x. 3x dividing out of 3x, I'm left with just 1. Okay, so now I got to make these denominators match. Okay. So let's see here. I see in this denominator I have 9. In this denominator I have a 3. How can I fix that? Multiply by 3. So we'll multiply the top and bottom by 3. Okay. So now I'll have 7 over 9x squared plus 3x over 9x times x plus 1. So now I have the 9's matching up. Alright, in this denominator I see I have an x squared, but in this denominator I only have an x. How can I fix that? Multiply by what? By x over x. Yeah, multiply by x. Okay. And we're taking this kind of a step at a time. You can do it all at once. It can be a lot to do all at once sometimes. We'll get 3x squared here over 9x squared times x plus 1. Okay, great. I've got a 9x squared here. I've got a 9x squared here. Are these denominators like terms? Are they like yet? Are they common? Yeah, this first one, what's it missing? The x plus 1. So I'm going to multiply this first one. I'm going to multiply the first one by x plus 1 over x plus 1. Okay, I'm going to like that. Okay, so it'll be 7 times x plus 1 over, and then I'm going to leave it unmultiplied. 9x squared times x plus 1. Now do our denominators match? Yes. So now we can add. When we add fractions, what part of the fractions do we add? Just the numerator, So it's going to be 7 times x plus 1 plus the 3x squared all over a single denominator, like that. And then we can simplify, right? Distribute the 7. So you get 3x squared plus 7x plus 1 all over 9x squared times x plus 1. And there's your final answer. Okay. We added two fractions together. Now you can check to see if the numerator factors, but this numerator does not factor. Okay, because sometimes the numerator may factor, and you can maybe cancel out something in the denominator, but in this case it does not. Okay. So let me have you guys try one here, and again we're gonna. I really don't like some of these that they give you here. Let me see if I like any of these in here. Oh, some of those are pretty straightforward. Yeah. All right. I'm just gonna make one up. So we're gonna skip 7 and 8 here. Forget about 7. I'm gonna give you your own here to try. So try this one. Let's have you add x plus 2 over 2x minus 2 plus negative 2x minus 1 over x squared minus 4x plus 3. Oops, sorry, I'm off the screen. I didn't realize that. Apologize. There you go. So add those two together. Now I'm going to help you guys get started first here, though. I'm going to have you help you by factoring the numerators. Sorry, factoring the denominators first. So this first denominator here, what can we factor out from that? 2. Yeah, so it'll be 2 and then an x minus 1. And then, can you guys give two numbers that multiply to make positive 3 but add to make negative 4? Oh, you're right. X minus 3, x minus 1. Okay. So there I helped you out some. Now you can see this first denominator is missing something that the second denominator has. This second denominator is missing something that the first denominator has. Okay, so fix that and then combine like terms. Add your fractions together. Okay. So get a common denominator and then add those things together. Okay. So give that a try here. Okay. Okay, let's see here. Okay. Now see what's missing those two denominators and try to fix it so they have the same denominator. See what's missing, right? This first denominator here, what is it missing from here? Okay. And the second denominator, what's it missing from here?
You doing the one on the right or left?
The left one. Sorry, the left. The one in red that I have. Just because I don't really like the ones that I have you guys try. So see what is missing. anyway, let's pause right here and take a look. Oops, I went too far back. Take a look at that problem that I gave you there. Okay, so there's your final answer there at the bottom right. I guess I should circle this here. Okay. So we're going to add these two things together. We factor the denominator, factor the denominator. What's missing? Here, I saw that there was a 2. This denominator is missing a 2, so I multiplied by 2 over 2. And I got 2 times the negative 2x minus 1, and I have 2x minus 3x minus 1. And then here, what's missing from this one? This one has an x minus 3, this one does not. So I multiply by the top and bottom by x minus 3. So it's x minus 3 times x plus 2, and then the x minus 3 in the order there. Now I have a common denominator. I can just go ahead and add these two things together. Before I put it all together, I went ahead and multiplied this out and got this plus the negative 4x minus 2. Okay, because I distributed the 2 there. And then I combine like terms, and that's my final answer. Okay. Notice again, when I add the denominators, right, they don't change because the denominators stay the same when you add fractions. It's still the same denominator. And you don't have to multiply out the denominator if you don't want to. But you should multiply out the numerators to combine like terms and stuff like that. Okay, questions on any of that? Okay. So what I've done for you guys here is given you an example, or basically what you can expect to see for tomorrow's quiz. Okay, these kinds of questions. All right. If you want to come in for set, we'll be able to go over these some, get you guys some extra help on this stuff, and then on tomorrow in class we'll spend a little bit of time reviewing. But then I also want to make sure we get this quiz taken care of. Okay. But this will give you a good idea about the different kinds of questions you could expect to see on tomorrow's quiz. Okay, including some of the stuff we just talked about today, right here. Okay, so that's that. All right. I will try to keep the quiz, within reason. Some of these graphs that we've seen have been pretty tricky, pretty challenging. Okay. So you will definitely see nothing harder than what you see right here for this homework assignment. But we'll see what I can do to try and help you guys out some too. Because I know this has been tough. It's not easy. Okay, so that's that. All right, that's the plan. All right, I'm sorry again I didn't leave you very much time to get stuff started working on here in class, but